Okay, so we have been talking about angles up until this point, and different types of angles and those kinds of things. So we are now combining those angles into triangles. So we're going to look at constructing triangles and just classifying those kinds of things. So first one is we have an acute triangle. Well, when I think of acute means less than 90, right? So an acute triangle is going to be a triangle with all acute angles. So I could have a triangle over here. Say this is an 80-degree angle. We'll call that a 60-degree angle, and we'll say this is a 40-degree angle. Okay, that would be an acute angle. All of the angles of my triangle are acute. Have an obtuse triangle. Obtuse means that it's between 90 and 180, right? So it's greater than 90 degrees but less than 180 degrees. An obtuse triangle is a triangle with one obtuse angle. And the reason why I'm just saying one obtuse angle is that it is impossible for a triangle to have two obtuse angles. So if there's an obtuse angle, it's going to be the only one. So we know what obtuse triangles look like, right? Here's a triangle, here's my obtuse angle. Let's say it's 120 degrees. Okay, that's an obtuse triangle. Right triangle, a right angle means that it is 90 degrees, right? So it's a triangle with a right angle. It's a triangle with a right angle. So that's just triangle, right angle, right? That is a right triangle. Those should all be a review for the most part. I also have what's called an equiangular triangle. What I can pay attention to is this angular part. So an equiangular triangle is a triangle with same degrees. So all of my angles are the same degree. There's actually only one triangle that's going to do that. So if you think about the sum of all of the angles of a triangle is 180. I'm going to divide that equally in 3 different spots. So what that means then is each angle of the triangle needs to be 60 degrees. I'm putting these curves in the corner. What that tells me is that all of those angles are congruent. Congruent means same, right? So all of those angles are the same. An equiangular triangle is a triangle with the same degrees in all of the corners. Okay? Then I have a scalene triangle. The scalene triangle has all different sides. All different side lengths. So none of them are the same. So whatever that looks like, right? It's not a very good triangle, but you know what I mean. Okay? All different side lengths. Then we have isosceles triangle. An isosceles triangle has 2 of the same sides. So that would look like this. And like we use the curve on the inside for the angles, I use little tick marks when I talk about the same congruent sides of triangles. So that would say that those 2 sides are the same, they're congruent. Then I have an equilateral triangle. So equiangular was all the same angle measurements. Equilateral says that they have all the same sides. Right, so I would have a triangle like this. All 3 of these are the same. That's what that means. All right, so we're going to classify these. if I look at the first one, number 1, I can see that I have a right angle right here. So that means that it's going to be a right triangle. So it's a right triangle. And then I also see that these are the same here. So it's going to be a right isosceles. Right isosceles. Number 2, I see a right angle here as well. So it's going to be a right angle. And then the only other thing that I can notice is that none of the side lengths are the same. So this is going to be a right scalene triangle. Okay, now I can see that these two are the same, so I know for sure it's going to be isosceles. Here's what I want to figure out though, is I have 50 degrees up here. These two here means that I am having the same angle measurement down here. So I want to figure out what each of these angles are. So I have 50 degrees. I know that the total of all of these angles is 180. So if I wanted to figure out what each angle was, I'm going to take 180 minus 50. It's going to give me 130. I'm going to split those into 2, which means that each of these angles is 65 degrees. So not only is it an isosceles triangle, we are also dealing with an acute triangle. So this is going to be an acute isosceles triangle. Okay, last one, also isosceles, but I'm noticing this 114 degrees here, which means that this is going to be an obtuse isosceles triangle. So here's what I want to do now. I want to look at all of the isosceles triangles and see if I can notice any other patterns. So each of my isosceles triangles I know have 2 of the same sides, but there's something else in common between all of them as well. So as I'm looking at it, I'm noticing that, for example, in this top one, I have 45 degrees here and I have 45 degrees here. If I look at number 3, I figured out that each of these were 65. Over here, I have each of those being 33. So not only do isosceles triangles have the same 2 of the same sides, they also have 2 of the same angles. So let's go back and add that to our definition. So an isosceles triangle not only has 2 of the same sides, it also has 2 of the same angles. So these bottom 2 angles are going to be the same as well. Okay, so we know that the sum of all 3 angles of a triangle is always 180 degrees. So this next part, what we want to do is we want to figure out, if I have these 3 angles, is it going to give me a triangle? Will I be able to form a triangle of those 3 angles? The way that I'm going to figure that out is by just adding these all together. I'm going to take 25 plus 64 plus 91. If that equals 180, then it will form a triangle. So let's test it out. Calculator. So I'm going to take 25 plus 64 plus 91 equals, 180. It was 180. I just did it twice. So this does equal 180 degrees, which means that this will form a triangle. We'll do the same with this next one. So I would have 55.5 plus 94 plus 31.5. So 55.5 plus 94 plus 31.5. Oh, that gave me a 181. So this is not going to form a triangle. So the second part says, if not, change the first angle so that it would. So in order for this to be 180 degrees, this would need to decrease by 1. So this would need to become 54.5 degrees. So go ahead and finish the other 4 on your own, and then come back and check when you're done. All right, so the next 2 would have been a no. they would not have formed a triangle. 85 should have become 86 degrees, and then 33 should have become 28. And then the last two would have formed a triangle. Okay, last page. So we want to figure out what the value of x is, and then classify each triangle. So we're going to say what it is. So I know for a fact that these two are the same. So this is going to be a scalene triangle. And I need to figure out what x is. So I have 2x plus 60 needs to equal 180. If I subtract 60 from both sides, 2x equals 120. So x is going to equal 60 for both of them. So not only is this a scalene triangle, it's also going to be equiangular. It's going to be an equiangular triangle as well. X is going to equal 60. Oh, it's not scalene, it's isosceles. I get those mixed up a lot. Isosceles. It's an isosceles triangle, equiangular, x is going to equal 60. If I look at the second one, again, I can look at these two. Oh, this would also be acute if you wanted to throw that in there too. Because then this one is going to be obtuse, and I can see that it's also isosceles. So I can do the same thing here. I would do 2x plus 120 needs to equal 180. If I subtract 120 from both sides, I'll get 2x equals 60, which means that x needs to equal 30. Okay, finish the last two on your own, and then you can check your answers back here with me. Okay, so it should have gotten that x equals 31 and x equals 28. Number 3 would have been a right triangle and a scalene triangle, and then I have a scalene and acute for number 4. Okay, the last thing that I want you to do, and I'll just have you do this on your own, is I want you to create a right triangle with two congruent sides. So right triangle means that there needs to be a 90-degree angle. Congruent means same. So I need a 90-degree angle with two sides that are the same. And then we want a scalene triangle. Scalene means that all sides are different. So all sides are going to be different. I want a 3-inch side, a 4-inch side, and then go ahead and measure the last side. Measure the third side to see what that would be, because you got to make sure that they're all different. Okay, that is all for 7.3.